Hello there. It's my pleasure to be taking you through this topic about building smart contracts that use oracles. This is actually a continuation of our live session that we had about building smart contracts with inheritance and libraries. So I promised that I was going to make a video that talks about oracles, how we can use oracles in our smart contracts. So that's what we'll be talking about in this video. So we're going to look at what what are oracles, why are they used, examples of oracles, services, and then we'll talk about using oracles in smart contracts, chain link. So what are oracles? An oracle is a bridge between the blockchain and the real world. They act as on-chain APIs you can query to get information into your smart contracts. This could be anything from price information to weather reports. Remember in our live session, we talk about random numbers, like for games. And so oracles can also be bi-directional, used to send data out to the real world. So with a blockchain like Ethereum, you need every node in the network to replay every transaction and end up with the same result, guaranteed. APIs introduce potentially variable data. That means that if you get a result now and then you want to get the result later on, it changes. So if you are sending Ether based on an agreed USD dollar value using a price API, the query would return a different result from one day to the next. And also API could also be hacked or duplicated. So Oracle solved this problem by posting the data on the blockchain. So any node replaying the transaction will use the same immutable data that's posted for all to see. To do this, an oracle is typically made up of a smart contract and some off-chain components that can query APIs, then periodically send transactions to update the smart contract data. So that's it about oracles. Why are they used? Basically, we are going to mention three reasons. Smart contracts can't reach the outside world. So that's one of the reasons. So why oracles are used. So you need something to connect them to the outside world. And that's what oracle smart contracts do. They connect the blockchain to the outside world. And then smart contracts can't invoke themselves. And also smart contracts are only a data store, which means that they are just like a database. So someone needs to put data into it. So it's only the data you put in the smart contract that can be retrieved later on. So that's why we need oracles. We need to use oracles in the blockchain. So examples of oracle services, we have Chainlink, we have Witness, Provable, Paralink, and then DOS Network. But then for the purpose of this video, we'll be making use of Chainlink. So let's see using oracles in smart contracts, Chainlink. Let's get started now. So to get started, we'll go to Chainlink website. So we'll have to click on that, develop with Chainlink. So what we'll be doing right now, the Chainlink oracle we'll be working with is that of randomness, which means getting random numbers. Actually, we want to build a smart contract that it's all about guessing and winning. So how it works is that you make a guess, and then if the guess is true, the person who made the guess, that's the person interacting with the smart contract, will be given some amount of Ether. So Why it's important for us to use oracles for this is because, take for example, someone makes a guess, and then that's later on other nodes need to verify if that person's guess was actually correct. So in the process of wanting to verify, then it's possible that another random number can be gotten that is different from the random number that was gotten when the person made the guess. And so it will now mean that the result is not the same, it has changed. Like we talked about APIs, that when you query them at another time, the data changes, the value changes. So with oracles, that problem is solved because the oracle gets the guess, and then that is what all nodes in the network will use to verify if that person's guess was actually true or not. So we'll be making use of this randomness, the chaining randomness oracle. So we want to get a random number. So these are steps for us to be able to do that. Here it says requirement, you need remix ID, MetaMask, and Wikibit testnet it. So we are not going to be using remix for this, we'll be using a Hadat. So but we'll also make use of the MetaMask and then Wikibit testnet. So where MetaMask comes in, it has to do with the creating subscriptions and funding the subscription. So that's where we actually need to use MetaMask. So right now, I want to create subscriptions and fund it. So we'll be doing that by clicking on this subscription manager. So it says create subscription. We click on that, and then our MetaMask is already connected. So we just have to create subscription. Confirm. Have to wait for a little time. It's confirmed. So we add funds to our subscription. But first of all, we'll be adding from our wallet. Says your wallet balance is 15.0 links. So we've already funded our wallet with links, test links, and also test Ether. So from that, we'll be funding our subscription with 10 links, add fund. So I have to confirm that MetaMask. So it's going to take a little while for this to be confirmed. So it says you can add consumers. When we talk about consumers, it means the smart contracts that will be able to use this chain link subscription. So it's just like you have a DSTV decoder that you subscribe. And so you can have multiple users, like multiple uh, decoders using that subscription. So also it is with this chain oracle. We can have more than one smart contract that uh, makes use of the chain oracle. So that's what consumers refer to. So when we create our smart contract, then we can add consumers. For now, we'll have to leave that and create our smart contracts first. So I'll do that later. So let's get to the next step, which is creating our smart contracts. Right here, we already have sample codes that has been given to us by Chainlink. So we're making use of this Chainlink code. We have just copied it right here. and paste it on our VS Code. So right here, you can see red lines are the imports are showing red lines. That is because we have to install Chainlink. So we'll get to install instructions here under introduction so that we can get the command for installing Chainlink. You see it here. So we'll copy it. Then we'll go to our terminal and paste it there. So we're installing Chainlink now. When we do that, you see that the red lines will be cleared off. So we have to change the name of the contract to the name of the name we want our contract to be, which is Guess and Win. It's a game of Guess and Win. So we can see that it's already installed. So those red lines are no more showing. Just as you can see there, they're no more showing. So then we'll have to edit sample code to our specification, what we want, how we want our code to be. So the first thing we'll do is to add subscription ID. We'll go back to the Chainlink website where we got our subscription. So this is the ID 1901. So copy it and then put it on our code. We're no longer passing that through the constructor. We'll have to put the exact figure of our subscription ID there. And so we'll change the number of words to 1. State variable, num words to 1. That is because it's a guess. We don't need more than one guess. So we just need one guess for the game at a time. More than one, just one random number at a time. So that's why we're changing that to 1 instead of 2. And so we'll also remove unnecessary state variables, such as the s_random words, s_require ID, s_owner. Remove those state variables. And also the modifier. So we'll have to remove the only owner modifier. Right here, it means that it's only the owner that can request for a random number. But then we want anybody to be able to play the game and then a random number to be generated. So we have to remove that. So we also remove the modifier. And then we'll update request random words to return the request ID. So now, what we want to do now is to add data structures. Want to add data structures. The first is mapping for request ID to correct guess. And then we add struct for guess. guess and the address of the player. So also we need a mapping from request ID to guess. Okay, so also we're adding an event that will be emitted when a guess is made. The request ID should be emitted so that the player can later check the correct guess. So we then add make guess function. We request a random number. Then save the request ID, the player's guess, and the player's address. Okay, so then emit the request ID. So the next step is to you can see, oh, we have to add public to that. That's the error there. Okay. So now go to the next step, which is to edit the fulfill random number function. Here it's written as fulfill random words. So you have to edit it. This function is called by the oracle when the random number is ready. So what we'll be doing, we'll add the request ID to the parameter. Then we get the random number from the array. Okay. Then we convert random number to dice number. This dice number refers to any number from 1 to 6. Okay, so retrieve the guess and check if guess is correct. Okay, so also need to add another function. Oh, we have to transfer some ether to the person if the guess is correct. So we have to do that before we go ahead to creating the next function. So we'll make that playable, and then we'll be transferring some ether to the person. Zero point zero 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 0.0001 ether. One 0.000001 ether. So that is it. Okay. So then we'll move ahead to adding a function to get the correct guess. The player can call this to check his guess. So now let's add the receive ether function so that our contract has ether to pay the winner. Okay, so right here we have to, it says function state mutability can be restricted to, so we have to add the view there. Okay, so we're okay. For this other place here, it says return value of low level core not used. So we don't really care about that. So we can leave that. It won't cause any harm. So right now we are done with editing our smart contracts. So the next step is to compile and deploy the smart contract. So here in our terminal, we'll put the command npx that compile. So wait for a little time for it to be compiled. So we have an error here. So it's telling us solidity version pragma statement in the file doesn't match any of the configured compiler in your config dot. Change the pragma or configure additional compiler versions in hard.config. Okay, so let's do that. We're using Solidity compiler 0.8.4. So we have to change that to 4. So run the compile again. Okay, so it's compiled successfully. Solidity file successfully compiled one. So now we go to deploy. I already have a script to deploy transaction and also script to add ether and also another script to make guess. So we will be deploying the transaction, the contract now. npx had run script slash deploy.ts. So we're using network, the Winkeeping network, deploying on the Winkeeping network. So I've already written this deploy script to print out the contract address right there. So we can see that it has printed out the contract address for us. So we're done with the deployment. Now I want to add it to our contract. So you have the TypeScript there. So I've written it to print out the transaction hash. You can see so we want to copy this contract address right here to replace the one A. So that's the contract address that we're using. So we have 0.0001 ether that has been added to our contract. And then it has we're running the command to add the ether to our contract. So it's done. We are done with running the add ether command. So it has been written. I wrote it to print the transaction as. So let's take a look at the transaction as. Look at it. So we'll copy that and go to ether scan to check if the ether has been added to the contract. Paste it there. You can see the contract address. So let's check it. Right, you can see that 0.0001 ether has been added to our contract. So that's successful. So now we want to make our guess. We make guess TypeScript. We paste the address there, the contract address. So this make guess, it returns the request ID through an event. Run that, make guess. Yes. Okay, so running this, you can see right here it's not successful. You can see a lot of errors. This is because remember we have not added consumers. We said we're going to add consumers later. So we have not added this contract address as a consumer on Chainlink. So that's why. So let's do that first so that I'll be able to make our guess. So we'll copy the address and get to Chainlink. Okay, so let's add our consumer right now. Facebook. So we'll have to confirm that on MetaMask. Okay, that's done. So we'll go back and run that make guess command. Okay, right here we can see the request ID. It's here. That's it. So let's quickly go to task scan to check our transaction. So we can see the let's refresh our page right now. Okay, so see the transaction here, make guess. Make guess, you can see the transaction hash, then make guess. Right here is my address, EOA, and then this is the contract address. So let's check that out by clicking contract address. So we can see that that's the make guess. Let's get to the internal transactions here to see what actually happened. So right here we see the transaction here. You can see that my address called the contract. You can see here it ends with 958. And then this is the contract address. It ends with 479. So let's check that to see. And then we can see if we get to internal transactions, you can see that this is the contract address. You can see that it ends with 479. So I called the contract address, and then the contract address, which is this that ends with 479, now called the Oracle. And so you can see the Oracle address ends with 7AB. So let's go back to our Visual Studio to check the address of the Oracle. You can see it here. It ends with 7AB. So that's the Oracle contract address. And so the Oracle contract is going to call my contract back to give it the random number. So we'll have to wait for a while for that to happen. Okay, now, so see, we now have the Oracle calling back my contract. You can see the call, my contract calling the Oracle. That was 6 minutes ago. But now let's see, 2 minutes ago, we have the Oracle calling back my contract. And so that means that it has given my contract the correct guess right now. So that means we have the correct guess. So let's go back to check, go back to our Visual Studio. Now, first of all, we have to take note that the guess we made, that's it there. I made guess, we made 4 as our guess. So we're going to check if our guess is the correct guess. So we will need the request ID. We have to get the request ID and then go to the get correct guess TypeScript and then put that. So we also have to change the address of this to the contract address. Okay. So we run that. Get correct guess. Get correct guess. Okay. Okay, so we have run the get correct guess, and then we can see that oh, the correct guess is 2. And remember, we said our guess was 4. Let's check, our guess was 4. So that means we didn't get the correct guess. And so that means we wouldn't have any data added to our account. But we would have kept on trying to see if we get the correct guess so that we'll have some ETAs. But we wouldn't want to do that. That is because you can see here, it takes a while for the Oracle contract to call us back with the correct guess. You can see it was 4 minutes ago, and then take a look at it, see 26 seconds ago. That's about 3 minutes plus for the Oracle to call us back with the correct guess, call the contract back with the correct guess. So we can't afford to spend that much time making guesses so that we can get the correct guess. Don't forget the important lesson that we have learned about how oracles work. First, we called the oracle contract. This is our address called the oracle contract. We called our contract when we made a guess. Look, I made a guess here. We called our own address, called the contract address. And then going to the internal transaction, we can see that our contract address then called the oracle address, called the oracle contract. And then that was 4 minutes ago. So we had to wait for the oracle here. The oracle, you can see it here, you can see the address, ends with AB. That's the same here. So we had to wait for 3 minutes plus for the oracle to call us back with the correct guess. So that's what happens. The oracle calls us back using the callback function with the correct guess. So that's how oracles work. So we have other application of using oracles. For example, we can use oracles to get price feeds for DeFi apps. We can also use it to get the weather condition for farm insurance smart contracts. So those are other applications of using other areas that we can use the Oracle smart contracts on the blockchain or can interact with the blockchain. So we have learned how to use the random numbers Oracle today. So that's just one application. So you can try out the other applications of oracles, other ways that oracles can be used on the blockchain network. So I'm sure you have enjoyed watching this video and learning how we can use oracles on the smart contract. Thank you. Thanks for watching.